Hi everyone. This is just a little bit of a change to how I normally do the YouTube videos for each week. So I'm going to be doing 597 and 598 on circle theory just to test out Microsoft Teams and how the interactivity will work if we plan to use this going forward. So first job, screen share. So the first clip was 597, which is about cyclic quadrilaterals. So here's a diagram of a circle with a four-sided shape in. Because it's a four-sided shape inside a circle, that's why it's called a cyclic quadrilateral. So the rule between the angles, we're going to try and see if we can see it using this diagram. So if I move this point around the edge of the circle, so around the circumference, you'll notice the two green angles will change in size. So if I put it down to there, you'll notice that those two both add up to 180 degrees. If I move that up slightly, then you'll notice they still add up to 180 degrees. If I move round to there, then again, you'll still notice they add up to 180 degrees. If I do the other ones, so if I move the one that's 120 round, then the red ones will change size. And once again, they should move that one to 100. They should still add up 180 degrees. So the connection between angles in a cyclic quadrilateral are that opposite angles add up to 180 degrees, and that's always the case. Just be really careful where the opposites are. So if it's really close like that, it's going to be that green one and this green one. These two will add up to 180, and then the red ones also add up to 180 degrees. Okay, so let's have a look at some questions. So on Haggerty Maths, the first couple are quite easy to do. And then it gradually just gets slightly trickier as it goes through, as you know. So the first question. Now, fingers crossed, if this works, I should be able to write over the top of it. Okay, so it's my computer being really slow. So the main thing you've got to recognize and look for in any circle is which angles they're giving you and which angles that they're asking you to find. So in the diagram, you should remember that when it's given as this, it's always the middle letter that is the one that you're interested in. So in this case, the C is this angle. So ACD, that one is 87 degrees. So in there is 87. Second one, BAC is 123. BAC is 123. So this one here is 123. Now it's asking you to find ABD. So ABD is this one. And it's also asking you to find BDC. BDC, so that's obviously the other angle inside the shape. So let's start off with ABD. So how are we going to find out what ABD is? Well, you know this is a cyclic quadrilateral because it's a quadrilateral inside a circle. And you know the opposite angles in a cyclic quadrilateral add up to 180 degrees. So the angle here and the angle here will add up to 180 degrees. So if I do 180 degrees, take away 87. So take 80 off, I get to 100. Take 7 off, I get to 93. So that means ABD is 93 degrees. And the second one, well, I've got to find this one, and you know this one and this one will add up to 180 degrees. So again, BDC this time is 180, take away, well, that's got to be 180 take away 123, which is given in the information. So if I take 120 off, I get to 60. I take another 3 off, I get to 57. So that'll be 57 degrees. So BDC is 57 degrees. Let's try the next one. So as you know, the first couple on Hecate are the same, and then they just get slightly more difficult. So let's try 4. So what have we got this time? So it says the diagram shows a circle with center O, and again it's given 2 angles. So let's have a look. Right, so we're given, let's jump on to question 8. So let's go to question 4. Remember what I said to you, this is a learning process. How to make sure we can do these if we're using it as lessons. So, number 4. Right, this time. So, ADC is 71. ADC is 71. So that's this one. Did I click the colour? See, the pen doesn't want to work this time. Okay, so ADC is 71, so that one's 71. BCD is 82, this one's 82. And what's it asking me to find? It says, find angle ABC and DAB. So ABC, let's just get rid of that again. So this one was 71. And this one was 82. So I need to find ABC. ABC, I've got to find this one. I've got to find this one. So once again, it's very similar. Just be careful with this word evaluate. That just means work out the answer to. So ABC, let's do this in a different colour. Right, so 71 is there. These 2 opposite angles in a cyclic quadrilateral add up to 180 degrees. So to get ABC, I need to do 180, take away 71. And you should know that is 109 degrees. So that means ABC is 109. DAB. So that one's 82. Opposite angles add up to 180 degrees. So second one would be 180 minus 82. So if I take off 80, I get to 100. Take off 2 more, I get to 98. So my 2 answers are 109 and 98. Let's try the next one. So we'll go jump to the end. So try question 8. Okay, so when this gets trickier is when you haven't just got to use one rule. So you've got to try and find the rules that you remember on all types of angles. So whether that's angles on a triangle, isosceles triangles, being able to use vertically opposite angles, parallel lines, etc., etc. So this one says circle, ABCD line circumference. So this time it's got AB and AD are equal. AB and AD are equal. So remember, put this line on. That means they're equal in length. BC and BD are equal. BC, BD are equal. So these 2 are equal in length. And then you've got also an angle that's 42 in there. So using the rules of isosceles triangles, if you know this line and this line are the same, then the base angles in an isosceles triangle are equal. So that one has to also be 42. So from that, can I get what this one angle is? Yes, I can, because I do 180. Take away 2 lots of 42, which is 84. And that gets me 96. So this top angle will be 96. Right, so the second bit then. Now, there's nothing else I can find at the bottom here, although I've not used any circle theories yet, so maybe I need to use a circle theory. So opposite angles in a cyclic quadrilateral add up to 180 degrees. So let's go for green. So that means these two, and again, remember I've said before, be really careful about which one you use. This one and this one will add up to 180 degrees. So if I do 180, take away 96. If I take away 100 from that, that makes 80, and I've taken too much away. So I add the 4 back on, and I should get to 84 degrees. So that's this one, is 84. Okay, so notice the bottom, you've got where the two red lines are. We put those on to say they're equal in length. That means that this one is also 84 degrees. So these two, the ones C and D, are both 84 degrees. So I can work out what this angle is. So that's 84, that's 84. Two lots of 84 is 168. And I've got to do 180, take away 168 because I've got a triangle there. And that will be 12 degrees. So let's see, what does it ask me? CBD, CBD. So it wants me to find this little angle, which is there, and is 12 degrees. Okay, so that's clip 597. Right, we're going to look at 598 now. So first of all, we're going to try it differently using PowerPoint. So 598 was alternate segment theorem. So that's this one here, number 6. Okay. So you've done majority of these now. There's 8 theorems altogether. And we're going to focus on this one next. So alternate segment theorem. So I'm going to go back onto here. I'm going to show you a demonstration of how this works. So if I take any point on here and I move that point round on the circumference of the circle, let's just try and reload it, see if it'll work. Okay, so I'm just going to move the point around the circumference and notice what happens. So the color coded, that's to try and help you to see where the pattern and the numbers are. So you'll notice as I move this point down at that red angle, the blue angles are changing in size, but you should notice something about those blue angles. Go right down to here and make that bottom one 20. You should notice that the top one is also 20, or in this case 20.02. So you'll show that if I do the other one. So if I let me move the blue one round, you'll notice that the red ones change. So let's move that one up to there. And we find that the top angle is still 20, but you'll notice what happens at the bottom. That one's 80. So what do you notice? Which one's the same? So this one here, the red one, is the same as this red one. And the blue, this blue one underneath here is the same as this blue one. This is called the alternate segment theorem. Basically, it comes from alternate means in the opposite position. So this one's on the outside at the bottom, and this one's on the inside at the top. So let's move that round there. Let's move this one up just so you can see it clearly. So this blue one is in an alternate position to this blue one. So that's in the alternate segment. So if I draw a line straight down there, then it's in the different segment to each other. And the same for the other one. So let's try drawing this on. If I drew a line on my diagram and went like that, there's 2 segments of a circle. This one is in an alternate segment to this one, because it's on a different side, basically. So remember, these 2 are segments. This one's on the opposite side to this one, so it's in an alternate position. So it's always the case when you've got a triangle, and I like to think of this as a line with a triangle that's balancing, just balancing on one point on that triangle. So at that point, it's balancing on this line. So these 2 are the same, the blue ones, and the 2 red ones are the same. So let's use PowerPoint to have a go at some of the questions. Okay, so first question. So let's read what it says at the top. The diagram shows a circle with centre O, so that's the centre. A, B and C lines come to the circle, so it's 3 points in the circle creating a triangle. X, A and Y line are tangent, so that line is a tangent to the circle. And it says work out ACB and ABC. So first of all, let's use what we know about the alternate segment theorem. So we know that this angle here and this angle here are the same. So those two are the same as each other. And then we know that this one and this one are the same as each other. Okay, so that means in this diagram, I've flicked forward, haven't we? In this diagram, where 63 is, the alternate position is over here. The 69, the alternate position is over here. So I need to find ACB. So ACB. Well, I've already found that just by using the alternate segment theorem, 69. ABC, ABC. Again, I've just used the alternate segment theorem to work out that one, 63. So this one is 63. Really, really straightforward if it's just a case of one thing. So remember, these are building blocks up to multi-step problems where you've got to use more than one circle theorem. Okay, second question. So this time, inside, I've given 64 and 60. I've still got a tangent. I've got a balancing triangle on a point. So remember, that point is balancing. So where's 64? So 64 is there. Where is 64 on the diagram? Well, it's in the alternate position. So it's on the outside of the triangle. It will be there. And then 60, where's that? Again, that will be there. So that's the first thing to do. Second thing says YAB. That's the one you've got to find. YAB. Well, that's straightforward again. That's 64. XAC. Well, that's this one. So that's 60 degrees. So another straightforward question. This time, though, you were given the angles that were inside instead. The third one. So this time I've got this angle and this angle given. So it says A, B and C lines come to a circle. X, A and Y line are tangent. So that red line is a tangent again. Work out ACB. Right, so the first one I need to find is ACB, which is this one. So that's 40, that's 71. So you'll notice you've got a triangle, the blue triangle. What do they add up to? Well, the angles inside, well, 180 degrees. So I can do 40 plus 71, which is 111. And if I do 180 take away 111, I should get the missing angle, which is the one I need to find first. So if I took away 110, it'll be 70. So that means 69. So this is 69. And ACB will be 69 degrees. XAC. XAC. That's this angle on the outside. Well, which one's the same as that using alternate segment theorem? Well, that's the same as that 71. So this one would be 71. I'm going to write it in there in case we need it in a minute. YAB. YAB. Again, you've got a couple of ways of doing this. You know these two angles plus that one, well, that's 180. So I can work out this angle from that. Or you can say, right, well, I know this one is 69 and that is alternate to this one. So I know that one will be 69 as well. And they both will give you the same answer. And the fourth one. So this is a little bit different. You've only got one angle given. There's some other information in the question. So same thing again. Line of circumference. There's a tangent. The red line's a tangent. AC and BC are equal. So what symbol could I put on those two lines to say they're equal? Well, we know that if I put that line on there, AC, and on BC, that's the same. So where else is 62? So using the alternate segment theorem, remember a balancing triangle on a point, 62 would be over here. So if I now use the 62, that means this one and this one are equal because base angles in an isosceles triangle, if you tilt your head, base angles in an isosceles triangle are equal. This is an isosceles triangle. If I do 180, take away 62, I would get 118 degrees. So then I've got to divide that by 2 because I know these two angles at the bottom are the same. So divide 118 by 2, and I would get, divide 100 by 2 is 50, divide 18 by 2 is 9, so 59 degrees. So that means this is 59, and this is 59 degrees. Forgot all my degree signs. So let's have a look what we need to find. ACB. ACB. Well, we've done that one, 62. And then ABC. ABC, 59. We've already done that one. And XAC. Right, we need to find this one. So again, you've got two ways of doing it. 59 plus 62, take away from 180. Or you can go straight forward. This one is the same as this one because the alternate segment because of the alternate segment theorem, they are both equal to each other. So that would be 59 degrees. And that's the final question.